And we're live. Hello, everyone. I think we're live, and we're live. Hello, everyone. This is VirtualJUG. My name is Alex Shalaev, and I'm very happy to see all of you here. Of course, I don't see you, but hopefully you are seeing me and you hear me well. This is VirtualJUG. We have an excellent session today. I'm very excited for this for various reasons. And let me just introduce our. I need to mute this other thing. Oh my God, this is horrible. Right? I know at least that the video works and the sound works perfectly. Excellent. So let me quickly share a screen and give you a few notes of the organizational nature. So VirtualJUG is, of course, the virtual Java user group. And today's session, we're going to talk about that in a second, is the test containers, how to test in prod-like environment with Docker. Our speaker today is Jonathan Vila, or you can find him on Twitter. He goes by @VilaJona. I'm sure he will be absolutely delighted to answer all your questions if you happen to have them, not right now, but after the fact, if you're watching this on YouTube as a recording. Then please, if you're watching this live, and this is very important, please join us in the VirtualJUG Slack workspace. There's the channel #live session, which is where you can ask questions and when you can discuss the things that you are seeing and that Jonathan will be showing you. You can discuss them live with other participants. And you can ask questions there. I will be monitoring those questions, and then I will be finding the opportune moments to interrupt the session, or I will store your questions until the end of the session, and then I will ask Jonathan to answer those. So this is the interactive moment there. And of course, you are encouraged to share the group in the session with your colleagues and friends and everyone in these challenging times, right? And if you have any feedback about the video quality, about the sound quality, about the sessions, about our pick of speakers, or anything really, you can ping VirtualJUG or @Shalaev, which is me directly at Twitter, right? And I would like to thank SNCC, which is the company that creates developer tooling for scanning security vulnerabilities, for sponsoring the VirtualJUG with our excellent Zoom accounts. Thank you very much, SNCC. Right. Without further ado, I will stop sharing the screen, and it is time to say hello to Jonathan. Hello, Jonathan. How are you doing?
Hi, fine. Thank you for having me here.
Absolutely. It's my pleasure. And I'm looking forward to this session. Testing is something that I think people could do more and could do more efficiently. So let's hear from you. And this is the stage is yours. You have the VirtualJUG watching you.
Okay, let's try to share my screen. Okay, this should be it. You should be seeing a slide saying testing as you were in prod with test containers.
Yes, I can see it perfectly, and our viewers as well.
Okay. Okay, so well, in today's presentation, I'm going to show you my experience implementing test containers in our project at Red Hat in an application that it is mainly an integration application that connects to different layers. I will show you later. And well, I will explain why our team decided to go a bit step further in testing. But this is the contents of the current presentation. So because now you can see in which step do you want to step out if you are not interested. I hope you don't do that, and I hope you stay, and mainly because I want to share with you, but obviously because I would love to hear your experiences and your questions, and I will be more than glad to answer them if I can, and if I cannot, that it is even funnier or more exciting, I will try to get the answer and investigate and give you back the answer. So to start the presentation, okay, I will give you a bit of context of who am I. So you are studying, you are watching to a presentation of one guy. So who is that guy? Well, I've been working as an organizer at BarcelonaJUG from 2012. Well, we tend to do 2 meetings every month, and well, when we are not very busy organizing JBCNConf, we try to do that, and we try to have very good meetings. Now, obviously, we are doing them online, virtually. I'm also co-founder of the JBCNConf. This is the biggest Java conference in Spain that we host every year. This year, sadly, we needed to cancel for obvious reasons, but we will host the 6th edition next July on 2021. So if you don't have better plans than being at Barcelona in July with beach, good food and good talks, then just come. I'm also working as a software engineer at Red Hat in the team application modernization and migration. We do mainly applications that are helping to migrate from different sources, let's say Camel2, or let's say WebSphere, or let's say Monolith, to cloud, to EAP, to Camel 3, and now we are about to release a new version that is also including rules to help you and analyze your application to migrate from Spring Boot applications to Quarkus applications. But this is another story. Okay, so you can find me at my Twitter handle and also my email, my blog. You will find a few posts about testing with Testcontainers and also introducing testing on Camel. And also you will find in my GitHub account all the work that I do for Red Hat in all the different projects, and also for personal projects, you will find them too. Okay, so which is the project that we are going to put Testcontainers into? So as I said, it's mainly is an integration project. So this is the Xavier application, that it's mainly a Camel application for receiving, processing, transforming, and sending content, and also to provide a REST API. We use Camel for that too. So this application receives a file from a user. I didn't have the drawing for a user, so this is the happy face. Not always is happy, but this is a user sending a file to our application. Our application will send this file to an Ingress service. Ingress is another Red Hat application. This application will do few things. We are not interested on those things, but we know that it will put this file into an S3 bucket. And when it finishes its task, it will send a message to a Kafka broker. Our application will receive this message from Kafka, will do some funny things, and it will send and persist a file in an S3 bucket. Then it will send a request to a JBPM server. So it does some calculations with some rules. It will give back the results of those rules, those calculations. And we will store some data in our in a Postgres database. We also use an external application in order to validate the RBAC, so the security, role-based access control, and that it also persists roles and users in a Postgres database. Okay, so we have all of this, and we do our coding, our pull requests. So those pull requests obviously have unit tests, testing specific features. We also have some integration tests in order to, well, to check that the clients are more or less working as they are expected to. But we wanted to have more confidence. We wanted to be very confident that when a pull request is merged to master, QA would need to only cover super weird corner cases and probably do some things with the UI that we are not doing in this particular use case. So what do we want to test exactly in our application? As I said, we already have unit tests and some integration tests, but we are also wanting to check that our listeners and our clients that are connecting to AWS are using the correct parameters, and that those parameters are not changing the behavior if we introduce any kind of issue in the code. Also with Kafka, when we connect to Kafka, we use different parameters, and we want to be sure that this is working as expected. And the same as with PostgreSQL, that the role of the user is okay, and the user can connect, whatever. Also, we want to check that our application can work perfectly fine with given versions. So we want to check that our code works with PostgreSQL 9.6. If it also works with version 10, fine, but it has to work with 9.6. Sometimes in our infrastructure, servers are moved from one version to another, but the requirement is one version specifically. So we want to know that this application works always for this version. And also for the JBPM server, we want to be sure that it is going to work with 7.3. Also, as I said, mentioned before, but now it's more, well, I will be more precise on this. When we connect to different layers, we want to be sure that the timeouts, parameters, and well, as we are configuring everything using camel routes, and sometimes the parameters are given inside the string. So we want to be sure that we haven't introduced any error. So it's easy to introduce an error in a camel route, and then you would say, okay, but your unit test will cover it. Yes, sometimes, because in several tests, we need to wave. It's like mocking. We need to mock S3 for obvious reasons. And in some cases, the client or the listener to S3 is being replaced by a direct one. So we are not going to test that listener, in fact. So we want to test everything as if we were in production, but without the risk of being production, and obviously without the issues coming to us, and also our boss checking on us. So also another thing that we want to check is those background async processes that are working, because as I showed you before, our application is sending information to the BPM server, and there are some things happening there. Our application sends the request, okay, that's fine. And what about the process in the key server? So we want to see that everything connected is working as expected, and not the usual, at least for me, usual in previous works. You are having assumptions. So it's like you test your code, you test your layer, and you consider that the other layer is going to give you the expected answer. So we want to be very sure, and we are not doing those assumptions. And also with, in this case, the JBPM server, we want to check that the configuration is working as expected. So the key server needs to work on a specific configuration, and we want to check that that configuration is the one that is making everything running fine. because our application is deployed on OpenShift, and there are several pods, services, routes working. We are not going to replicate OpenShift, but we are going to work everything on containers, and expecting that the different pods, versions, and clients and listeners are working fine. And the best thing, we want to test these in every single pull request that we have in our CI process. So we have our code in GitHub and our builds in Travis. So we want to be sure that every pull request that is going to be merged to master effectively is succeeding, considering all the tests that we are going to do before being merged to master. Also, I want to mention that in our test, we are also introducing tests to check, let's say, performance. So we are executing the happy path tests. Okay, that's fine. We upload a file, we check, we'll wait until our request is 200. And once we have it, we check the response, and then we compare. Okay, that's fine. This is the happy path test. But we also test, let's say, performance with big files. So we upload a super big file, and we expect that, considering the resources on Travis, the result is returned as we expect in a time that we consider is okay. And also, we are uploading, let's say, 3 files. As we have 3 consumers, I think, in the listener, if we upload 3 files, those 3 files should not affect anyone, should affect the others. As we have 3 consumers, everyone can be processed in parallel, and we are uploading a big and a small file, and we expect that the small file, even being the 3rd one, is going to finish way before about than the other 2. But we also do a test sending 4 files, and we expect that the 4th file will be finished very long after the first 3 ones have finished, just because we only have 3 consumers. So we expect this to happen. This is also a use case that we have introduced in our tests. As I said, we want to have it in CI. So in the left, you can see the page in GitHub. Every pull request has this check, so it will succeed or not. And on the right, you can see, well, the UI from Travis, where you see the time and that has been succeeded. I have to mention that, as I said before, we are doing a lot of tests, and some are performance tests. Therefore, the build takes a lot. So it's about 45 minutes. Okay. So here is when test containers come to the rescue, because we can do something similar as the production environment using containers. Here you have the URL for the test containers webpage and also the Twitter handle. I totally recommend you go there. They have good guides, and documentation is very good. And even more than this, you can find them in Slack, and they are super kind and super helpful. I have to say that I've been very pushy sometimes. I know that you don't have to do that, but they have responded super well. So I'm more than thankful to all that tip behind test containers. So for those that do not know what is test containers, that I've been talking about and talking. Okay, so let's suppose that it is a Java library that supports JUnit test. You can use it in JUnit 4, JUnit 5, and Spock, if I'm not wrong. And it simply will create Docker containers. And if you follow this flow below, is Well, it's a matter of you have your app. Your app has your JUnit tests. There you will consume test container modules. I will explain them later. And test containers uses the library Docker for Java that you can find in GitHub. And in the end, you will have a Docker container. So you start with your app, and then you have your environment populated with several Docker containers running. And these are some of the modules. So test containers, as they know that sometimes it's not super easy to have a library, database, or any other tool up and ready running with Docker, they have created several out-of-the-box modules that you can use. They are optimized. They are easy to use. They've made a lot of effort on those modules just to make your life easy when you use them. And also for different tools, you have several. Those are super common and super known tools. For instance, if you want to deal with Kafka, you just simply use the Kafka container. That's it. But if you want to use it manually, you should use Kafka, Zookeeper, and connect them and blah, blah, blah. This is the super easy way to do it. And well, I've used it, and it's super easy and super fine. So if I want to have the environment as if I was in production, well, I need to substitute, to replace each of the components with a container. Okay, so for almost everything, we can have, let's say, real one-to-one relationship with the production container or production pod, production tool, except for one, that it is AWS. So it's obvious that I'm not going to run AWS in my test, and it should not be okay if I connect from my test to AWS resources, because this is not an ephemeral test. What I want is that my test comes, runs, checks or unchecks, and disappears. This is what I want. So I don't want to connect to external services. That's why I want to replicate mainly S3. So for S3, we have two. Ingress uses Minio. This is a tool similar to S3 on the test profile, let's say. So we will use everything. The interface is similar, so it will use Minio to persist the files in that bucket. We are going to use local stack just because, well, I heard about local stack and I thought, wow, sounds nice and sounds very good. And you can also have different services from AWS replicated in local stack. So for our purposes, we are going to use local stack and Minio as if we were persisting files in S3. For the rest, those are the real containers that we will have in production. Okay, so which are the tasks that we can do with containers? Well, I hope everyone is still awake, and if I'm boring like that, please, I don't know, shout, send me a pigeon, whatever, in order to make this more fun.
No, okay. No, you're good. You're good. We are still here.
Okay, nice. Okay, so which are the tasks that you can do with test containers, with those containers? Well, first you need to define, obviously. So you need to define which are the containers that you are going to have, which are the parameters that you are going to inject, which is the configuration for each one. There are three ways of doing this. As I said, you can use an out-of-the-box module, or if you have, let's say, a Docker image, you specify which Docker image you want to use, and it will check in your local repository. Not it will download from Docker Hub, and you can specify the image and the version, or you can just have a Docker file, and you want to create the container or the image on the fly during your test. That's also perfectly fine. And in our project, we use all of them. Also, when you have your container defined with all the configuration, then, you need to start it. So it can be started automatically using JUnit rules, or it can be started manually. Manually, you can start one after the other, or you can do it in parallel. So you will specify a list of containers to be started, and you can also introduce dependencies between them, just saying, okay, you have to start all these in parallel, but this one needs to be started when this other is already ready. I will explain later this concept of readiness. Okay, so apart from starting it, okay, we have defined our container. Now we have started. Well, we have our memory going crazy with all the containers running. But one common task is to check the logging. So is what I said. What I say is that you don't need your umbrella unless it is raining. In this case, you don't need the logging unless it fails. So when it fails, logging is handy. So having the logs from all the containers grouped somewhere will give you information about, I don't know, Kafka container is failing for whatever reason, no memory, not enough memory, you are sending an incorrect parameter, you are using latest as the version and they have changed something, whatever. It's useful to have the logs. Also, you need to connect to them. So they are not going to leave isolated. So at a certain point, you need to connect to them. You are going to connect to those containers or from another container or from your application. In both cases, there are two different concepts. So one is the IP and the port. The IP can be different if you are running locally or if Testcontainers knows that you are running everything inside the container, that it is the case in Travis. And the port is always random. So it's like you're not going to find PostgreSQL running on, I think it's 5432. So this is the theoretical port, but this is not the port that Testcontainers will make the PostgreSQL container to run. So you need, at some point, you need to get that port. We will get to that. And once you have done everything, well, you need to finish. If you are running in Travis, well, you can finish, but Travis will take care of finishing you. But it's better to finish. So there are two ways of doing this stop. So one is doing manually at a certain point in your code, or automatically. For that, JUnit rules, if you are using JUnit 4, is handy. So it will take care. And once your test suite is finished, those containers will be stopped and decommissioned. So now we know which are the tasks. So let's let's see which are the ways of defining containers. As I said, we can have the out-of-the-box module. So in that case, we have a class, PostgreSQL container, and we create one instance of this, specifying which are the parameters that this container will use in order to start. In this case, we have defined the database name, the username, and the password. That's it. Or we can use a Docker file. In this case, for our Ingress application, that it is another Red Hat application, well, we have the Docker file that we download from GitHub every time our test runs. So one of the steps of our test is, okay, now go to GitHub, download the Docker file, well, the repository, unzip it, get the Docker file, and we'll create the container for that Docker file with these variables, these properties. With the exposed port, okay, this is the internal port, that it's going to be exposed as a random port. With a network, in this case, we are specifying a shared network that will be shared by other container. We are also specifying that we are going to use an external logger. So our application has, or that class has, a logger. So this container will use this logger in order to output the logs. And every message in that log will be prefixed with the text that you put here. So you will see the messages from different containers differentiated using this prefix. This is very handy when you have several containers and you need to see what is happening. And also you can use a Docker Hub image. So in this case, it's a generic container as the previous one, but we are specifying directly the image. We could also use the version, but in this case, we are using latest because we don't care with that particular container. You can specify it also, which is the entry point of the container, the exposed port, as I said before. This is the network alias and network. This is where we specify which is the shared network that this container is going to use. And this name is going to identify this, let's say, machine. So two machines that are sharing the same network can connect to each other using the name. Also, with the log consumer, as before, it's going to output all the log using this miniolog prefix. And sending or injecting these environment variables into the container, well, with these values to that container. So if we know now the different ways to define the containers, which is our particular use case. So for Minio, we are using the Docker Hub image. We are using two containers, Minio and Minio MC. This container MC, what it does is it creates the bucket in the Minio, and it creates several things more. I can really remember, but they are connected together, and the Minio MC will start, will do some things, and will finish. Then we use an out-of-the-box module, Kafka container, that is optimized. It's super easy to use and fine. For local stack, exactly the same is an out-of-the-box container. For the Ingress, obviously, Testcontainers is not going to produce a module out of the box for our own application in this case. So obviously, we need to rely on something. This application relies on a Docker file. So we create a container using a Docker file. For the JBPM server, in this case, key server, we are using a Docker Hub image specifying which is the specific version that we are going to use. For the RBAC, as it is an internal application, the same. So we are going to rely on a Docker file. And for the two Postgres that we are going to run, we are going to use the PostgreSQL container out-of-the-box module. So once we have all our containers defined, okay, so now we need to start them. Well, we can do it manually. It's very obvious with the start method. Or we can do it manually, but in parallel. So what we do is we use deep start from startables, and we pass a stream of containers, and it will try to start them all in parallel. But when we define our container, we can introduce this depends on. So we know that Minio MC will wait until the Minio container says, I'm ready. And the last way is automatically. So we can use, if you are using JUnit 4, you can use rules, and then those rules will execute and start these containers for you before the test starts, and it will close or stop them when the test finishes. Another concept is logging. As I said, for me, is important, especially when you are starting to create this environment. And there are several things that fail at the beginning because obviously you don't know, and you are experiencing and you are checking. And it was very handy to have the log, and passing the logger to the container and the prefix. Then we have in our Travis log in the output console, we have all the log, and we have the logs prefixed with the prefix that you specify. So you can see here a sample of a log, and you see that there are several logs from the AWS log and also the key log. So then you can see what every container is doing in the log, and you can, let's say, split those logs easily. The next step is to connect to a container. So if we want to connect two different containers, well, probably I already shown before, we use this with network alias and this with network. And you can see here that create buckets container, that it is a Minio MC container, shares the same network as the Minio container. That's because internally, there are several things configured to connect to a machine called Minio. Then with this shared network, it will be fine, and you don't have to modify its internal behavior because they are in a shared network. That was very, very handy also. But apart from that, from your test, you need to configure your application with certain properties. So once, in our case, when we go to production, our application gets deployed, our pod gets deployed in OpenShift, and there are several environment variables that are configured for that deployment config. That deployment config has the host for the Kafka server service in that case. The host or the address for the PostgreSQL service, because when we are in OpenShift or Kubernetes, we are always using services, but we are configuring that in our environment. So our environment in CI in testing has few values, and in production has other values, but those are configured on the platform. In this case, we need to get this information from those containers that are running. So we need to have the IP address, and we need to have the port. As I said, Testcontainers is creating random ports. Well, every time that our test runs, we will have different port for each container. So we need to get those ports in order to configure, in our case, Spring Boot, to inject those values into Camel and other libraries that we are using. I also explained or talked about the waiting to be ready. So by default is the ready means it has started. Obviously, we all know that starting doesn't mean being ready. There are several things that need to happen before you get ready. In this case, we can also use the wait strategy. So we want to say, okay, this container depends on this other container, and it has to start after this first container is ready. Or we can check in our unit test if a container is ready. And the value for that readiness can come from waiting for, I don't know, a log in a message in the log, or waiting for an HTTP request and expecting a status code, or waiting for the health check expression. So this will give the I'm ready value a new meaning. So you can work with a startup strategy if you don't care if they are mainly containers that are going to take not much time starting, or if you prefer to do the wait strategy, I encourage you to do this one. And when we have everything running and we need to configure our test application, in our case it's a Spring Boot, what we did is to say, okay, Spring, you need to use these for the context configuration. So it's a matter of implementing the application context initializer and passing this as one of the initializers in the context configuration. And once you do this, and considering that in this version, we had all the containers as a static, everything was running before the context was started. So once the context was started, we were able to retrieve all the values from the different containers. Now we have refactored this a bit, and you can check in the code in the GitHub repository, and we have splitted this, and we are not having static containers. But yeah, there are different ways of doing this. And with this, we have, as you can see, well, the Minio host, well, there's a method that will retrieve. It's only to not duplicate code, but we are going to get the host for this mapped port. We are going to have also the first mapped port for PostgreSQL. We are going to get the username and password for the container. Well, there are several things. Even for the S3 on local stack, we are going to get the service endpoint and the sign-in region. So these are important things that we need to introduce in our application that we are going to get from the containers once they are running, and put them to Spring Boot in order to inject to all the libraries. And in the end, if we want to finish the containers, it's very obvious. Or we do it manually, calling the stop method, or, as I said before, if we use a rule, this will take care of stopping and decommissioning the containers. And you would say, okay, but these are pictures, these are characters, but show me the code. So now I am going to try to share my screen, my other screen. Oleg, can you just simply kick me off sharing my screen? Because I don't know, but I don't see how.
I'm on it. 1 second. Let me quickly share mine, and then I'll stop sharing my screen. This is a hack, but now you can share your screen again.
Okay, thank you very much. Okay, so I'm going to share my VS Code. You should be seeing my VS Code.
Loud and clear.
Perfect.
I mean, clear and clear.
Yeah. Okay, so this is our, let's say, our end-to-end test class. And as I said before, here we have the initialization of the Spring Boot context with the same class we saw before. Now, what we do is we create this end-to-end test that, in our case now, it extends from a Testcontainers infrastructure class. This class, what it has is all the static containers. I lied to you before. I said no static, but it's not true. Those are static too. So these are all the containers that we are using in our class, as you can see, and we are stopping them manually. Also, one of the things that I said to you before is that we were cloning and creating images on the fly from the GitHub repository. In this case, is like this. So we are going to GitHub, downloading the repository, and then we are unzipping, and we will use exactly the file that we want to use. So because this is, as you can see, for instance, here, this RBAC is going to use the Docker file that is inside that GitHub repository. So we are using the latest code on these containers. So if we go to our end-to-end test again, okay, we have that infrastructure that is going to be executed, and our test, let's... These are the top results.
Sorry, Jonathan, can you please, since somebody kind of interrupted you anyway, can you increase the size a little bit more? Yes, please. Yeah, I think yeah, one more maybe.
Sure.
I saw the questions in the YouTube chat. Thank you very much. This should be absolutely perfect.
Yeah, okay, perfect. So what we do here is that, well, we start containers, we create and start our containers, as I said. And let's go to a test. So in this case, what we do is we init camel. So we start, what we do is to say camel, do not start the context. I will do it manually, just because that way I can wave or advise, it's another way of saying, with endpoints that are simulated. In this case, I'm replacing few things in order to connect to Minio instead of connecting to S3. So this is what I do first time that my test executes, because this is executing every time that the tests are running. And I'm being sure that these simple requests are giving an error, and we are treating the error as expected. As I said, let's check. So for instance, a regular test, this is the happy path test. So what we do is we simply send files. So as you can see here, we are sending a tar.gzip file to our application, and using a waitility, this is a very good tool also to not introduce thread sleep. So you are saying, okay, you need to wait at at maximum this amount of time and doing a poll interval. So executing this code every time, in this case, 100 milliseconds. And it will go to a database and check that there is something expecting there. So it's checking for the initial savings estimation report that we are having the number that it is in the database is what we are expecting. So we are calling every 100 of milliseconds, expecting that our report is generated. We are going to also check that there is a file in S3, and we are also going to do several checks on the database. Okay, this is the let's say happy path. It is uploading a file, and then it is executing several REST calls in order to get, in this case, well, this report, workload inventory with a limit, without a limit, different reports from our application, as if we were the client of the API. Well, then we are checking using soft assertions. We are checking several values in our reports returned from our API. Okay, so once the happy path test have worked fine, okay, we want to have another test that it is the performance test. Okay, so what we are going to do, we are going to send a big file, and we expect that that report is going to give us exactly 142, in this case, virtual machines. And this method, what it does is simply, with a wait, it is sending requests to the application, checking for a report until we have 200, and there is no summary models null. This is a part of the response, and then we parse this message and we respond with a number. That's the number that we are expecting here. So this is a big file. Then we are introducing known errors. So in this case, well, we have a file that could come from the user with, well, few things that are null or empty or wrong in the file. So we are doing exactly the same. We are uploading the file and we are checking the response. And you have to take into consideration that when we upload a file, this file goes to our application. This application sends the file to the Ingress application. This stores in Minio. This also sends a message to Kafka. Our application sends the message to the JBPM. JBPM does some calculations. We retrieve the response. We store responses in database, and then we can call requesting a report. So everything is working because we are uploading a file with errors, and the response should be this and exactly this from the whole system. Obviously, we also have unit tests that are validating that the specific calculation in the JBPM, given this value, will return this other value. Obviously, we have that. But we want to check that the whole process is working as expected. Again, we have another one that it is without cluster. Well, it should behave differently. Another error also when we introduce another issue inside the file. Another one. We are checking different errors inside the files. I'm going down because I want to. Okay. As I said, we are having consumers. So when we have several analyses running larger files, this should not affect smaller files. So here, what we are doing is that we are uploading one big file, so 5,000 VMs, one that it has, I don't know, can't remember, but thousands of VMs. Another one that it has 5,000 VMs, and another small one that has dozens of VMs. So we are expecting that the small one is answering or is executing when we expect and not later, and that the value that we retrieve is what we expect and not other. And yeah, we are having also checks for S3. So we want to check that the file, when we upload a file, that is like a ball in a game, that it is hitting corners. So we want that our file that we upload is stored in S3. And I want to check it as a result of different interactions. And we do that. So we expect the file to be uploaded, and we check that the file is there. And yeah, basically this is the code that you can check in GitHub. And I will try to share my screen again to continue with the presentation. You should see the presentation, right?
Yeah, all good.
Fine. So this has been all the presentation, all the code, all the knowledge that I have, a small knowledge, a bit of practice only, that I wanted to share to you. But I always want to share the knowledge, also sharing the links to those libraries and to those tools that I've been reading a lot. So here you have the page of Testcontainers, the Twitter handle. If you have any doubt, any question, they will answer very quickly. They are super kind team behind it. The library Docker for Java, if you are curious about it, and also the GitHub repository for the code that I've been showing here. Also, I want to share this non-tech thing. So I've had once a teacher that every class, he was sharing several books that were not related at all with the class that we were doing, just because it is like mind feeding, I don't know. So I want to share these 6 books that I've read. I love them a lot. I've liked a lot reading them. You have 2 novels. The second one, The Last Caton, I would say is similar to Da Vinci's Code, but way better. First one is an historical story about the building of the Santa Maria del Mar here in Barcelona, but it's very nice. There's a Netflix series on it. And then if you are curious about how our mind works, I would suggest Drive, that it is a very good, that talks about motivation and what motivates us, if there is in fact something that motivates us. So I would read. Also Thinking Fast and Slow, that it's about the concept of the 2 different brains, one the rational one and one like the sensorial one. And it's very, very, very interesting. And about sci-fi, I love sci-fi. And I would say that the Futurological Congress is awesome. It's a short book, but very fun, about simulated reality. There's a movie, but I would not recommend to watch it at all. And also Ubik, I would say that this is one of the best books I've read ever about simulated reality, and I love it a lot. But I would say that I love everything from Philip Kalik. And that's all. This is all I have to share about test containers and testing, like if you were in production. I expect that every one of you knows which movie is this one. And yeah, you here have my Twitter handle if you need to ask me something, or my email, my blog post, and my GitHub repository. And that's all.
Thank you very much, Jonathan. This was an absolutely excellent session. I feel like I'm smarter, and I feel like I enjoyed this, and I know from the questions that people enjoyed it as well. So very quickly, there are a number of questions where at the top of the hour, maybe I'll just skip some. If your question isn't asked, please reach out to Jonathan if it's not here. Right, but I will try not to miss anything. You will put the slides up somewhere, and
sure.
Like absolutely,
Yes.
we will tweet the links. So if you want the latest news about the past sessions or the current sessions and the future sessions, Twitter @virtualjug, we will update all the information there. Quick questions from the very beginning. Do you know if there is a test container for Spark cluster, for the Apache Spark cluster?
I haven't. I assume that the question means an out-of-the-box module from Testcontainers. I would say no, but I don't see anything that prevents you to start a container based on Docker Hub image or a Docker file if you are doing something special with that.
Yeah. I know that there is also the Docker Compose module for test containers. So if anything, you can definitely start a cluster through the Docker Compose functionality. Right. Very good, very good, very good. The code is available on GitHub. There is a URL in the slides. And those are all the questions from the YouTube chat. And let's go into the Slack where I was marking them for myself.
So the second one is not a question?
Yeah, because like the question was, is there a link to the sample code?
Okay. Okay.
And yeah, there was a link in the sample code. Yes. So a quick question from the very beginning of the session, when you talked about the performance tests. Do you run the performance test on every build? That is a question from T Grip on our Slack.
Yes, but that doesn't mean this is the way to do it. So yes, we have it like this, and I think we shouldn't do it. But at the moment, as we really don't care about that time that Travis is taking for each pull request, because we are a small team, we don't have 20 pull requests every day. So we don't really care about that time, but it should be separated. I agree with that, yes.
Right, very good. Karsten is asking whether they know if you can launch a browser with the graphical user interface from Docker.
Well, in fact, Testcontainers has something, I haven't used it, but has something about, let me check, which is the module. With Selenium, but I'm not sure because I haven't checked. But from the description, it says, okay, you can use it with Selenium web browsers. So I think you should do it. You should be able to do it. I haven't tested, I haven't checked, but I will check because I'm interested on the question. So I will check.
I think it runs the headless browser and just with the like JavaScript driver and everything, and just renders everything in memory, right? And then you can take screenshots on failures, which is how you usually do the Selenium tests.
Yeah.
I think maybe we need to find an expert on Selenium and invite them to VirtualJUG, because this
exactly.
could be an interesting session.
I think it's interesting. Yeah.
I think you can run a browser and forward the X11 socket to the host if you want, and that's how you could get the UI from stuff running in Docker. But for the love of the universe, I don't know if you can do it on the first try or in the given operating system.
In fact, I haven't pasted, but it's a typo on my side. There's the WebDriver module. So as it says in the web page, says test containers can be used to automatically instantiate and manage containers that include web browsers, such as those from Selenium HQ's Docker Selenium project. So
Right.
yeah, I think they have done something.
Right. Thank you. Aromanos is asking, what would be the strategy to write or insert the test fixture data? Not sure if Testcontainers provide an API for that, or are you supposed to write the custom code using respective clients yourself?
So I assume that the question is about inserting the initial data into the database.
Yeah, I think database, or maybe creating Kafka topics or something, right? And,
okay.
Just the fixture data for the tests, right?
Yeah. In our case, it is about, well, the topic is already created. So in Kafka, if I'm not wrong, when you send a message for a topic, unless you configure it in another way, the topic will be created by default. So in that case, I'm not sure. For databases, I think I need to investigate about this, but I think you can use an SQL file in order to instantiate the initial state of the database. But I will check that.
Right. And T-Grip with another question. Why do you always download the Docker file from GitHub, and why not download the file only once? I think it's about the architectural choices for the tests.
Yeah, we download every time because we don't want the file to be part of our project. So if this is an external project, so what we do is simply connect to that GitHub and we download the Docker file. We don't want to maintain, because then we will have the responsibility of updating our Docker file according to the Docker file of the external application.
Right. That makes a lot of sense. Everything that can be easily obtained outside
exactly
should not be maybe managed. Right. I'm gonna give 3 seconds or 5 seconds to the next question to appear, because somebody is typing.
Okay.
I would like to take a moment to thank you, Jonathan, for the session. It's been really good. Thank you for coming, and thank you for educating us all. I know Testcontainers is a very cool project. I like it myself very much. I've blogged about it as well.
Oh, sure. I will check it out then.
That, like, if you do you allow me a shameless plug?
For sure, obviously.
Right.
Yeah,
So
yeah.
Testcontainers is one, like, and sorry, like the audience, you will enjoy this one. Testcontainers is one of the great libraries in the Java ecosystem that has no analogs in other language ecosystems, right? So it would be absolutely excellent if something like Testcontainers would have, like, say, Node.js bindings, right? But there is, as far as I know, there is none, because the Testcontainers team writes in Java,
Yeah.
right? So what you can do, you can use a certain polyglot virtual machine that is capable of running Node and is also capable of running Java code, which is GraalVM, of course, right? And you can run your Node applications, and you can use test containers from your Node applications for tests, right?
Okay.
And yeah, I had a blog post about that, which is very cool.
I will check. This sounds very interesting. Thank you.
I mean, if you have colleagues who are writing Node.js and you would like to share how amazingly you can manage the test infrastructure, that might be interesting. Right. So the last question of today, Kappa is asking that they're using the standard. Yeah, I don't think that's a question. That's a response to somebody else. Right. Oh. Thank you very much. Oh, excellent. This is a wrap. Jonathan, it's been a pleasure. Thank you very much. We will update the website, and we'll tweet the links, and the recording of the session is immediately available on YouTube. So thank you everyone who was with us listening to this, and see you next time. Thank you very much.
Thank you very much, and happy coding to all of you.
Happy coding.